Today's session. It's all about SQL Edge to Cloud, and it's very appropriate that this session be called Future Data Driven, because we're certainly going to talk about things about SQL Server that are going to feel very futuristic to you. So let me just kind of move forward a little bit here and show my kind of opening Microsoft slide. There's a couple of things I want to point out to you. First of all, hey, I'm Bob Ward. I'm an architect with Microsoft Azure Data Team. Maybe you wonder why it doesn't say SQL Team. It's because the SQL team is part of the Azure Data Team, and I'm certainly a part of that. Anything that has the word SQL in it, that's part of Microsoft, I seem to find myself being involved, which is why it's appropriate I talk about SQL Edge to Cloud, because I've been involved in a lot of the technology you're seeing today from the edge to the cloud. Now, you can follow me on Twitter if you want to keep up with the latest information that's going on with Microsoft and SQL Edge to Cloud, or you see these URLs at the top right-hand corner here. The deck that you see right now in front of you is available on AKMS Bob Ward MS, and many of the demos I'm showing you can be found here on the GitHub repo site. I've got a final slide with resources when we're done today, and I'll put those up there again in case you miss seeing them right now. I'm sure you're going to have some questions, so we'll do some demonstrations. What kind of talk would you give if you didn't do some demonstrations? I'll do that for you today. And when we do those, we'll pause for a second and take some of your questions at each segment of those demos. And at the very end, hopefully I have time, a few minutes for some remaining questions. So with that, let me get started on the topic of SQL Edge to Cloud. And I said this is future data driven, but I think it only makes sense to look a little bit back at the past of SQL Server to see why it's amazing the innovations we provide today are very futuristic. I started at Microsoft in 1993. Many of you on the call today are like, I wasn't even born then, and that's okay. Hold those comments if that's your situation. But back in the day when we started in those early years with SQL Server, we were a desktop database engine. That's what we were known for. Inexpensive, worked really well on desktops. This is back in the days of diskettes. Yes, diskettes. Okay, that's a quick live moment here on my drawer. Yeah, look at that. The original diskettes for SQL Server OS 2. Yes, my friends, everything for SQL fit in this rubber band right here back in the day. But over time, we definitely evolved. We had a reputation of becoming a department server. You start to think about SQL like 6.0 and 6.5, even 7.0 and so forth back in the 90s. But then very quickly, we pivoted to become an enterprise force with things like performance and price performance and ease of use. So all of a sudden now we were becoming a big player in the game of databases at an industry level, even at enterprises. And as we pivoted, we started doing innovations that makes what I believe SQL Server a data platform. That is, we started putting SQL in clouds in Azure. And then we started innovating in different operating systems like Linux and containers. And then finally, we started adding more to what we call SQL Server, things like machine learning services. Altogether, we became all of a sudden now a data platform, not just a database engine. But look at the top. One of the things we've always done across time is continue to innovate on what I consider a proven database engine in the areas of security, performance, and availability. And you're going to see that theme throughout everything I'm going to talk today. Now, with that context, let's look at what do I mean at the landscape of the assets of what I call SQL Edge to Cloud. It all starts at the bottom here with something called Azure SQL Edge. Yeah, that's right. We're running the SQL Server engine and that data platform on things like IoT devices. We'll talk in a second. What do I mean by that? And then you know the latest version of SQL Server we released a couple of years ago called SQL Server 2019. A lot of great innovations in that platform. We'll talk about those as well. You run SQL Server where you want it, on premises typically, right? And then you think about SQL Server on Linux, which we started in SQL 17. We continued on that path. It opened up new doors for us to run things like SQL Server in containers and even on systems like Kubernetes. Now, if you look at the top of the screen here, this is where, the top of the screen, you'll see this is where it fits into SQL running in Azure, in the public cloud. So this is SQL Server on premises mostly. This is SQL Server in the cloud, in Azure. And it comprises of SQL Server running in Azure Virtual Machine, SQL Server, Azure SQL Managed Instances, and Azure SQL Database. And we'll distinguish between these three and why you might choose one versus the other. And just recently, we decided to bridge these worlds with something called Azure Arc. Azure Arc enabled SQL Managed Instance and SQL Server on Azure Arc enabled servers. And we'll talk at the very end of today's presentation and see a demonstration of what exactly is Azure Arc enabled SQL Managed Instance. Now, many people that look at this diagram right here that I've shown before go, wow, this is pretty amazing. I didn't realize you guys had SQL Server running in all these places, but I can't learn all of this. I'm sure there's different languages to learn, different environments, but I'm here to tell you today that number one is still the core engine. It's still the same SQL Server engine running across these. Now, in some cases, it's versionless, so it's a little ahead of some of the other places that SQL runs, but the same fundamental aspects of security, performance, and availability exist across every one of these things you see right here. And then second of all the languages you know and love work across these assets. The T-SQL language, which you know and love today, works the same across SQL Server 2019, Linux, Edge, public clouds, and Azure Arc. So the basics of doing queries and query performance tuning works the same across of these. And if you're going to build applications with popular languages and providers, they're also going to be compatible across these. We kind of have this idea of develop once, run anywhere. And then finally, I'm sure you have tools that you love, things like SQL Server Management Studio or PowerShell, or even SQL Command or command line utilities, or even our new Azure Data Studio. All of these are compatible to run and connect into any one of these SQL servers. So it's a lot of assets across a lot of different places, but familiarity with things you know and love, like the language, the core engine, and tools. It's my intention for the rest of this session to kind of dive into each of these, some a little deeper than others, and explain kind of like when would you use one of these versus the other. Boy, you're going to get done here. In some cases, you may say to yourself, I'm going to use multiple of these actually, instead of just one versus the other. Okay, let's start with Azure SQL Edge. And the way to position Azure SQL Edge is not just what you see on the screen right here about time series and data streaming and AI built in, or the fact that you can move data to Azure from these devices or run it even on ARM devices. The story here is 3M. 3M, a manufacturing company that came to us at Microsoft and said, look, IoT is a huge part of our business with manufacturing devices and things that run Internet of Things. Our problem is this, they generate a lot of telemetry, but we don't want to always feed that telemetry directly to the cloud. What we would love to do, we would like to push processing down on these devices, which in some cases are not connected to the internet or connected to the cloud. In fact, we would like to push down things like machine fault prediction down to these devices. So we would like to take machine learning models we've built and run them there. Can you do that? And we're like, they've got a SQL Server engine that runs in a container. A container could be very exciting to be able to put on these devices, even for things like ARM. We have machine learning services, right, where we could actually run machine learning models you train and run those along with the engine. And then we know about things like time series and data streaming. We've done these kind of technologies before. Can we wrap that into a bundle? We sure can. So what you have found is that you can take SQL Server, an application, you can connect it to a SQL Server engine and develop it somewhere, and then you can deploy that into an IoT device, running with container images on ARM devices, combined with things like even Kafka data streaming and streaming analytics. You can take telemetry, process it right on the device, do analytics, take the results and run the machine learning models, and generate predictions directly on the device without even being connected to anything. And then when you're ready to connect, you can connect and then upload those results to the cloud and do further analytics. That's exactly what 3M needed, and that's exactly what Azure SQL Edge does. And one of the things we've done to make this successful is find a way to take SQL Server and turn it into a very small footprint, almost like 500 megabytes in total size. That's all we needed to give you most of those core engine functionalities. For example, column store indexes still work on this device just like they do in SQL Server. So that's the story about Azure SQL Edge, very popular technology for developers looking to push down processing, data processing to the IoT Edge. Okay, you may have seen this slide before when I was presenting SQL Server 2019 and learned about all the amazing innovations we've done, whether it's big data clusters and data virtualization, or now running SQL Server in all these different paradigms and different operating systems and devices with database compatibility, or running machine learning models, or even Java extensions with SQL Server, are giving amazing new performance capabilities with no code changes. And we'll stop right there and use Bank et al. As a customer as an example. Bank et al. Was testing SQL 19 before we released the product. Literally, we hadn't spent a lot of time with them. We said, hey, here's some of the functionality we have. They went through and did testing with SQL 19 using the latest DB compat levels for their database. and saw major gains, like 40, 50% increase in performance with many of their applications. And they didn't know why. They thought, okay, something's wrong here. Turns out intelligent query processing was dealing with many different scenarios they struggle with, and they gained performance with no code changes. And so we told them that's actually a true story. You really can achieve that. We innovated by continuing to enhance always encrypted using things like enclaves, or even providing data classification functionality to help people with things like GDPR compliance. And then finally, the amazing story of accelerated database recovery was part of it. Banco Tao again saw benefits to this because now we solve the problem of long-running transactions holding you hostage to log truncations or long recovery or long rollback problems. So ADR being very innovative. Now let's take a second to do a demonstration. You know, it's one thing to look at slides, but wouldn't you like to see some example? How did Banco Tao, in the case of performance, you know, gain some of those performance enhancements with no code changes? So let's look at an example. Let's bring up here Azure Data Studio. If you've not seen Azure Data Studio before, it's actually a pretty cool tool. It's compatible as a tool natively to run on Windows, Linux, and even MacBooks. And I'm using, in this particular case, something called a SQL notebook. I love these SQL notebooks because I can combine documentation with code, and then I can save the results of queries to a file. In fact, this is an example of me showing you the benefits of table variable deferred compilation. Table variables being an issue that many customers have run into before with getting accurate statistics, which leads to performance problems. And that's what happened to Banco Tao. So in this particular case, I have a stored procedure I'm running. I'm using the Wide World Importer sample database, and I'm amending it with a procedure. And here, I'm just going to run some sort of like analytic type query in the proc. And if I go out here with a compat level of 130, which is prior to SQL 19, if I run with this old compat level, which is part of Wide World Importers, I can go run this procedure like 25 times. It doesn't take a long time to run this, but if I run it a lot, which is common for applications, I can see here that I get a total execution time of like 21 seconds. Well, that doesn't seem too bad for 25 executions, but developers who've looked at this says, I know this can run faster, way faster than that. Why isn't it? Well, it has to do with how statistics are being estimated for table variables. So I'm going to come along here and scroll down in the notebook to these results and show you I'm not going to change the proc or change the code. I'm just going to go to the latest compat level with SQL 19, and I'm going to run it again. And now what took 21 seconds now takes 3 times less, 8 seconds. No code changes, just faster. And so what we've done is taken common query performance tuning patterns customers struggle with and find ways in the query processor to make changes where we can recognize these patterns and make things more intelligent for you. There's a whole range of features in this space, and you can go look up intelligent query processing. Another cool thing about this technology, it's all cloud first, not cloud only, cloud first. We build this technology in Azure, customers use it there, and then we're able to take a collection of that and put it in a major version of SQL Server, and this is a great example of that. Okay, let me go back here to the deck. And then, let's see, there's a slide right there. I want to stop and see if there's anything here in the window, any questions that have come up.
No questions so far, Bob.
And it's no problem because there's going to be some technology here. You're going to go, well, I got some questions because I don't understand how this stuff works. So please, if you have a question right now and you still want to put it in the window, I can come back to it in the next demonstration I'm going to do. All right, let's move on and talk about containers. Now, a cool way to tell you a story about containers is what happened is in a conference a couple of years ago, back when we were doing in-person conferences, please, I want to skip back to that again. I was at an event and I was talking about SQL Server Linux and containers, and I was using my Windows laptop to show this with Docker. And somebody in the audience said to me, hey, I'm not feeling the love as a MacBook user. I mean, I get that you're Microsoft and you think you know containers and Linux now, but hey, all of us that spend time in Linux are really MacBook people. So I just don't want to even run Windows on my MacBook. You need to help me out. I said, here you go. I have a challenge for you. And I didn't know this was going to work. I just did this on the fly in front of like 500 people. And I call it the Mac Challenge, the Bob Mac Challenge. The SQL Mac Challenge, I think is what I called it. And the idea was this. I told this person, I think within 5 minutes, you can get SQL Server up and running on your MacBook with no Windows software. And you can connect it with a tool with no Windows software. And this person said, fine, I'll tell you what, I'll take your challenge. And tomorrow on Twitter, I'll post the result. I thought, uh-oh, Twitter? Wait a minute. I didn't know it was going to get that viral. Sure enough, got on Twitter the next day. Somebody came to me at the event and said, Bob, this person went on Twitter and said you were wrong. And I went, what? He said, yeah, the person said that you said it's going to take 5 minutes to do this. And actually it took 3. And how did that work? Well, what happened is because SQL Server container images are portable, you can run them anywhere a container engine supports it. So our Linux containers, turns out, can run on MacBooks without Windows software, right? So you can just run these containers. See, they use Docker to pull the SQL container down, the SQL image, run SQL Server. Then they use Azure Data Studio, which there's a native version for MacBooks, and in 3 minutes they're up and running SQL Server. So that has actually led to the ability for developers now to run SQL Server in their local environments without having to have a development server. Hey, DBAs, would you like to be able to not have developers mess up a dev server that you have to maintain? Sorry, developers, we love you, but you mess up servers. So give them containers. In fact, notice here that it's lightweight. It reduces the need to have a bunch of virtual machines. Hey, containers don't replace virtual machines. Don't think of it that way. They supplement it. You can now run multiple containers, as in this diagram here, in a consolidation way to run multiple SQL instances inside a virtual machine. That's an often thing it's done. And let's bust the myth right now. Containers don't use some layer to talk to the operating system. They are just processes run in an isolated way using a container runtime, and they have the necessary files in their container file system, their image file system, but they always talk directly to the host operating system. So don't think that containers can't be fast. We have customers running containers in production, and guess what? Like DP01. And guess what? When containers run on Kubernetes with SQL, it is SQL container technology. So we've got other examples where SQL Server runs really well in this environment. Now it's consistent, but also notice it's efficient. In this diagram right here, did you know you don't patch a container, you switch containers. So if you need to go to a new cumulative update for SQL Server, you just switch to the new cumulative update image, pointing your databases, including your system databases, to it, and you're up and running to a new CU within seconds. And by the way, if the CU caused problems for you, you can roll back to the previous container that had the older CU image. So it's a very efficient way, a lot less downtime and no patching required type environment. You may be thinking, does it support DevOps? It sure does. When you get this deck, click on this link for this video. I did a demonstration at Microsoft Build last year using the power of containers with DevOps to automate the DevOps development testing lifecycle. Okay, so let's spend a little time now talking about Azure SQL, but let me go look at I do have a question in the window here. Let me just ask this. We have set up an elastic query, meaning external data source, external table, and those queries run so slow. How can we improve that performance? So that's a great question, and it deals with Azure SQL. I guess I'd have to go see specifically what kind of external data sources you're using and what kind of queries you're using. I would recommend actually use some standard troubleshooting process here to see what does the plan look like for these queries and find out, first of all, is there a problem with the plan? Like, is it a lot of scan going on? Is it even allowed to use indexing? That kind of type thing. So first, go spend some of that time. We also have some very good documentation on how to use Elastic Query properly with sharding. That may help you as well for that reference. Okay, we talked about Azure SQL Edge, SQL Server Linux containers. Let's talk, I'm just doing a quick time check here. Let's talk about Azure SQL. And it comes in 3 flavors. SQL Server and Azure VM, which is you running SQL Server in Azure. We maintain the infrastructure, Microsoft does. You run it inside a guest operating system. You manage that. You pick a specific version of SQL Server. Let's say you had a vendor that said, you got to be in SQL 16. I don't support SQL 17, 19, or even the cloud, but I'll support SQL 16. Well, you can then take your SQL 16 SQL Server and put it in Azure, and it'll be compatible because it is just SQL Server running in the operating system of your choice. There are some manageability features we keep adding in this space, so we keep trying to bridge the world between this and the other 2 offerings for Azure SQL. One called Azure SQL Managed Instance, which is a full-fledged SQL Server instance with SQL agent and replication and link servers, but it's platform as a service. So we're going to manage a versionless SQL Server. Yes, no more patching required by you. We're going to maintain high availability and disaster recovery automatically for you. And we're going to provide a series of services to make it feel very managed. For example, you don't even worry about where you place database files anymore. We handle that for you. And then Azure SQL Database is indeed what its name implies. It's just a database. It's better for maybe cloud-born applications where you're first starting out in the cloud saying, I really just need a database. I don't even need all the instance features. Just give me the SQL Server engine from a database perspective. And then we can light up new things for you like serverless and hyperscale scenarios. So these are your three choices. The two on the left are really meant mostly for migration scenarios. SQL Server users migrating to Azure VM or to Azure SQL Managed Instance, or maybe even migrating from like a product like Oracle. And then Azure SQL Database is really more for these new cloud-born applications. Technically, you can migrate to Azure SQL Database, but we found most customers prefer building new apps that are going to go use this database type functionality. Allscripts, great example of a company that uses all of this stuff. They wanted quick lift and shift to the cloud, so they went to Azure VM. They wanted Azure SQL Managed Instance in some cases because they didn't have to worry about a specific version of SQL Server, but wanted some of his instance capabilities. And by the way, in some cases, they've even actually moved to VM and then at some point realized they could flip over and migrate to Azure SQL Managed Instance. And we're going to talk about today. We have some pretty cool technology to help you do that. Okay, and people have asked me before, though, I really don't understand still what is the difference between SQL Server and Azure SQL Platform as a Service. And I've got some resources as well. If you don't get that message today, it's totally understandable. I've got resources for you at the end of this session that are going to help you dive deep into this. Okay, you and your environment today for SQL Server can do all of these things right here. You can support business continuity. You can support high availability. You can do backups. You can do even long-term backup retention. You can even replicate your data across the world. But you have to do all of that. SQL has the features for you, but you have to manage it. In Azure SQL Platform as a Service, all of this is done automatically. Maybe geo-replication is done automatically, but did you know that your databases are automatically geo-redundant backed up when you just start using them? But if you also can extend your Platform as a Service footprint and do it geo-replication across the different Azure data centers. So think in terms of Microsoft managing some of this for you. You get to do some knobs and configuration and tuning of how you want this to work, but we are responsible for making this work in Platform as a Service using the power of SQL Server plus other cloud services. And then if you think about scale, like today, when you need to go scale your application, scale a virtual machine, sometimes you have to go like migrate to a whole other server. Not in Azure SQL. You can just say, I want more CPUs, and we just make that happen with very little downtime. We offer new advanced security features like Azure Defender for SQL to help you look for injection attacks and threat attacks. We provide a versionless SQL Server. Yes, I'm telling you right now, don't worry anymore about patching the operating system or SQL Server anymore. We do that for you. We even support things like maintenance windows where you get to choose when that happens. And then we provide a lot of built-in monitoring and intelligence. You're going to see some examples of that. Here's one example, though, is automatic indexing. When you go to that Azure database, this cloud-born application system where you're going to pick a database, wouldn't it be nice if we could, Microsoft, provide some suggestions or even automatically help you maintain indexes? That is a functionality that just comes with Azure SQL Database. So there's a lot of advantages here. Yes, there's less control of some of these things, but in many cases, you just pick the declarative choice of what you want, and we manage and make it happen in Platform as a Service. Okay, so when you do go to Azure SQL Platform as a Service, you have choices on what we call additions or service tiers. Today, what do? You pick a VM size, a certain set of limits for resources, and then you go off and pick like Enterprise Edition or Standard Edition. In Azure SQL, since we're versionless, you don't do that. What you do is you pick service tiers. So let's first pick general purpose. This exists both for Azure SQL Database and for Managed Instance. By its name, it's for most business workloads. So when you declare, I want a general purpose service tier, we're going to use remote storage within Azure. You're going to get a reasonable set of I/O performance. You're going to pay less, but you're going to light up new scenarios like serverless, where you can take advantage of auto scaling and even pay for only what you use compute. Now, the P stands for a primary replica. You get a single replica, and you need to think of the high availability built in for this option like a failover cluster instance. We provide that out of the gate. So you declare you want general purpose, We put your database and files, which are redundantly stored within Azure. But if a failover occurs, we just spin up another SQL server and point them to your database and files, kind of like a failover cluster instance, and you're up and running. Now, there's another service tier edition called Business Critical that also exists for Azure SQL Database and Managed Instance. And as its name implies, you got lower latency requirements, you want to get faster recovery, and you even want like a readable secondary. This is Business Critical. We're going to use local storage and always on availability groups built in. Yes, you don't even configure it or set it up. We just do it for you. So that's why you see the P's, the S's, and the R's. You automatically get secondary replicas, which makes failover faster. You get faster I/O performance because we're using local storage. It's going to cost more for you, and it is going to light up in some cases features like in-memory OLTP, which would not be available in general purpose. But notice the R. For free, as part of Business Critical, you get to get a read replica. So all of a sudden now, you just say, I want Business Critical. We deploy this for you behind the scenes automatically. It's all versionless. It's all deployed for you. You get an availability group that you don't even realize we're running with. You just know I've got SQL backing up these replica designs, and I get read replica if I want to for free. Now, the final option, only for Azure SQL Database, is hyperscale. Now, think of hyperscale from a storage perspective to be in between these options. We're going to use a combination of local and remote storage because hyperscale is intended for very large databases. Think of like 100 terabytes or more. You know, how do you cache 100 terabytes on a local compute server and not pay a ton of money? Well, what we do is we use a tiered architecture with page servers and SSD caches within the local replicas and so forth, but we still have the ability to have replicas. Notice here, the multiple R's. This is where you can scale further. It only shows 4, but you can even go further than that today. So if you've got highly scalable storage needs and read scale requirements, and you want to scale as you just add more, hyperscale could be your option. In fact, if you need an extremely large database and you need to go to platform as a service, that is your best option today, only available today for Azure SQL Database. Okay, and just some customer examples to make sure you understand, like you probably heard of these customers. AccuWeather picked Azure Database General Purpose because it was a very simple way for them to get going in the cloud with new cloud-born applications. And they didn't need the business critical options. They just needed a basic database. They got that built-in high availability. H&R Block, an example of a customer that said, you know, I need the more business critical type options. I've got some SQL servers. I got some SQL and Azure VM, but I need that ability to do read scale with read replicas. And I also need the ability to have that very low latency, fast recovery scenarios for my company. And finally, ClearSale had that read scale requirement, very large database size. And what they wanted to do was they knew they were going to grow. So they picked only a couple of read replicas, and then they just started adding more as they needed more read scale. Now, here's one of the beautiful things behind what I'm showing here. It's something called a service level agreement. We got kind of putting more money where our mouth is. So I told you about all these automations for high availability and disaster recovery. We have very specific, what you call nines, that we put in a service level agreement. So when you sign up and pay subscriptions for these platform as a service databases, because remember, you're paying at a subscription level for these things. You don't pay an actual huge license. We provide a service level agreement behind it. But speaking of license, if you didn't notice already, I've said it already, you can use something called Azure Hybrid Benefit. You can take your existing SQL Server licenses and apply those to cloud subscriptions to save money, whether that's an Azure VM, managed instance, or an Azure database. So there've got to be some other things about the cloud that gives me value, and there certainly is. Azure Defender, I mentioned earlier about allowing you to look at vulnerability assessments or things like injection attacks or get notified of somebody attacking your SQL Server. We just announced a new blockchain for SQL called Azure SQL Database Ledger, and something called Azure Monitor SQL Insights, which I'll show you a demonstration here in a second. And then I already mentioned about intelligent query performance. So we continue to invest in the cloud first on intelligent query performance and making the query processor very smart for you to adapt to your code, get faster with no code changes. So these are things that you get as a value of being a part of platform as a service. Let's look at an example of SQL Insights. So today, you're going to go to platform as a service, and one of the things you're going to see missing is access to the operating system. And you're like, uh-oh, I use Perfmon. Like, where did that go for me? So we have something in preview right now called Azure Monitor SQL Insights. You're seeing an example right here on your screen. I have set up, it's a VM that you set up and run, and this VM is going to monitor some Azure SQL databases and managed instance. And let's see what this kind of looks like. So for an Azure SQL database, you're going to notice a couple things here. As I pick it, I have the ability to set up to look at my primary and my secondary. This is a business critical service tier. So already I can look at statistics, not just at the primary, but also to the secondary that's going on, what I'm reading from the read replica. So if I scroll through and click on resource in view, you're going to start seeing information that almost looks like a perfmon, things like CPU and memory and IO usage. Or how about some graphs for things like transactions per second or batch requests per second? And notice that because I pick multiple databases, I start seeing comparisons with these things across them. Or I'm going to look at space usage, man. I'm seeing it now more in a graphical way to see how much space or what I'm paying for am I using. I even get to go look at things at a more detailed transaction level, especially when it comes to latency for IO, or even a more detailed graph for how much throughput of IO I'm doing. And here's what I love about it. When I go to explore metrics, I now have at my disposal a plethora of perfmon charts, perfmon counters to add to charts and do any kind of analysis I want to do at any time. Now, if I go back to monitor, I also can pick a managed instance. And in this managed instance, you can see here, I'll bring up the details here of the instance. I have multiple databases as part of it. But first, I'm going to go right to the overall instance utilization, the basics of CPU and status of my database. Oh, look at this. This is powerful. You want to look at weight stats, a very common way to look at performance. I can drill into different types of weight stats, and then I can even go further to the actual weight type itself to get detailed statistics about what those weights look like. And managed instance has all the other capabilities you saw from database, but look at this, things like even memory consumption at the clerk level, which you, if you're into the internals of SQL, may use that today in your SQL Server. So that is Azure Monitor SQL Insights. If I didn't show you at the beginning of the screen, the top here, one thing I didn't configure is that you have the ability to do this with Azure SQL VM as well. So if you set up SQL Server in Azure Virtual Machine, even putting an availability group up there in the cloud, you can configure to monitor this as well. I'm using the power of Azure now to monitor SQL assets across many different paradigms, all in one place. The cool thing also about this technology is that it's open source. So we publish the details of what we're collecting, and we publish how we put this into log analytics. You could then go consume that and do whatever you want. Get alerts, any kind of type technology you want to put on top of that. So that is an example of Azure Monitor SQL Insights. Okay, let me just double check, see if there's any other questions here in the window. I don't see that. I'll keep monitoring here. But let's talk a little bit about cloud migration, and then in today's discussion with Azure Arc, because I want to show you a demonstration, brand new technology, right? You may be thinking today, I love SQL Server, right? And I got plenty of examples where I need to keep it on premises, but maybe some SQL servers are ready for this migration discussion, and I don't know how to get started. So the first thing you should do is go to this website, aka.ms data migration. We keep this updated. This is a one-stop shop of content to learn how to migrate SQL Server to Azure. You just go whenever you want, just pick your source and your targets. We'll start giving you information how to do that. But you may want some tools. So we've got a tool called Azure Migrate. Now this is Azure Migrate's a service across all of Azure. We're snapping into that Azure Migrate experience so that you can do things like, I've got a VMware environment with thousands of SQL servers. I don't know what to do with all this stuff. So you can run an Azure Migrate to go discover all their SQL Server assets, give you an inventory, and then even give you an assessment. Where should these go? If I want to migrate, should it go to virtual machine or managed instance? And by the way, if I made that choice, how much would it cost? Or I have blockers that's going to prevent me from making this move to Azure. So check out Azure Migrate, great new experience. Now, you may know a SQL Server already that you want to migrate, but you just want to kind of see a little bit of what's going on. You can assess it with Azure Data Studio. There's a new extension in public preview with Azure Data Studio with a wizard. Not only can you go through the assessment process, but you can migrate not just inline, but online. We can use log shipping technologies to migrate your database using Azure Data Studio right to managed instance. Or you might want to also migrate online with our Azure Database Migration Service or our new log replay service, which is designed to migrate SQL Server backups to managed instance. And in fact, it's a really good scenario if you want to make that move from SQL Server and Azure Virtual Machine to Azure SQL Managed Instance. So we think we have the content and the tools you need to show you how to do this migration journey. Now, the final part of our story today is a new technology that we announced here this summer. We've had it in preview for a little time. We actually announced it last year in preview, called Azure Arc. So Azure Arc is a family of services at Microsoft that cover everything from SQL servers to Windows servers to Kubernetes, you name it. Specifically, though, we came out this past summer, just recently here, and announced Azure Arc enabled data services. And there is one of those services, Azure Arc enabled SQL managed instance. And you're like, Azure Arc enabled SQL managed instance. So I see this, I see the Azure Arc thing. I'm not sure what that really means, but I see SQL managed instance. And Bob, you just told me an Azure SQL managed instance is a platform as a service. So here's what we're trying to give you. We're trying to give you the feel and the power of platforms as a service, but any hardware and anywhere you can install Kubernetes. So that's what we're meaning here. We're meaning that we're going to give you Azure SQL managed instance, that functionality, but you manage it. You manage the infrastructure. You manage the Kubernetes platform which it'll run on. But look what you get. You get automatic updates. You get a versionless SQL server. You get scale very easily. You can deploy this very quickly because we're going to use container images behind the scenes. Remember, I talked about how fast it is to deploy and patch and switch to those. We're going to do that behind the scenes. We're going to give you unified management. And the reason we're going to do that is the word Azure Arc means arcing between on-premises and the cloud. So now all of a sudden now you can then connect yourself, attach yourself to Azure, go into the Azure portal and view Azure SQL managed instance, just like we go view an Azure SQL, even though it's running in your environment. We have security, just like you have in SQL Server today, but then we add on to that role-based access control from Azure that we can push down and help control who can deploy and access that SQL Server. And then the final important point is this. This is the first flavor of SQL Server ever that you're running in your environment where we're going to bill you like you run in the cloud. So you have a subscription model now where you can pay for SQL at a subscription rate based on your deployment of this in any hardware, any Kubernetes. And I'll just point out one important point. When I say any hardware, any Kubernetes, I mean any Kubernetes that we support, which includes multi-cloud. So if you've got Kubernetes running in, say, Amazon environments, Google environments, other types of environments, we support that as well. One of the most popular options for Kubernetes today is OpenShift. Red Hat's OpenShift. We fully support that, along with Azure Kubernetes Service, or just your own flavor of Kubernetes that you manage in your environment. So let's look at an example of that. Let's see what this is. Okay, so Rick is saying, I'm still wrapping my brain around MI and Arc environments. What the heck is this? And I'm trying to, but I'm learning a lot about it. Okay, well, Rick, here's a demo of what this looks like. So let's go first to the portal. Okay, this is a resource group that I've built, and you're going to see some new things here. First of all, this is an example. I'm just using Azure Kubernetes Service, AKS, for my environment. It's very easy for me at Microsoft to deploy one of these. That's why I chose it. But notice here that when I connect my Azure Kubernetes service to Arc, I get this. I get a Azure Arc Kubernetes because I'm connected now. And what happens is when you do that, we deploy software, what we call agents, as pods in your Kubernetes cluster that connects itself to Azure. There's proxy support, all the things you need to make it secure. But now you're connected together. And you have different ways, by the way, to be connected. You can be indirect connected, which is occasionally I want to connect, or direct connected, where I'm always tied into Azure. Now notice this here. Here is what's called an Azure Arc Data Controller. What the heck is that? Let me just redo that here. An Azure Arc Data Controller, that is a piece of software that we're going to install, again, a series of pods to help orchestrate what happens in that Azure Arc environment and talk to the Azure Arc Kubernetes software agents to make things coordinated to automatically upload billing information and metrics and logs and things of that nature. And then finally, look at this. This is a SQL managed instance from Azure Arc. If you click on this, it's going to look a little bit like a managed instance, like an Azure SQL managed instance. Now, this is something in the Azure portal, but remember the software is running in Kubernetes in your environment because you've attached together, you can see things in the portal. Now, one example now that might be the following. Notice here, if I pick on metrics, I can go here and pick on SQL Server, and I can just see basic CPU usage. Remember, this is SQL Server running in a set of containers in your Kubernetes, but we can talk to Azure and upload this information anytime we need so you can view it in Azure. Now let's flip over and show you an example of what it looks like from a more practical level. I've got a virtual machine as a client. And right here, what I have, I'm going to expand this a little bit, is the following things. I've got, first of all, let me slow down here. I've got three things I'm connected to here to make sure we understand. First of all, this is an Azure SQL managed instance running in the public cloud. And you'll notice over here in Object Explorer, it kind of looks like a SQL server, right? You see most of the icons are there, but notice the difference up here to this server, which is using an IP address and a port number. You see always on high availability shows up and a couple of other things. This looks more like a normal SQL server. This is kind of like a SQL server. This one down here looks like the one in the beginning, like it looks almost the same. Now, why is this one look more like a SQL server? This is an Azure SQL managed instance, which is kind of like that, etc. So let's flip over and look at PowerShell to get some real, let's get some like real nitty gritty details out of this. So this is running on Kubernetes. So I'm connected to Kubernetes. And what the first thing I'm going to do is I'm going to show you this. These are pods that make up software for the connected Kubernetes to Arc. So we install this by default, and they're going to handle talking to Azure. All of this stuff's going to help manage and talk to Azure when we need to upload things like metrics or we need to push things down. Once I'm connected to Azure, I can deploy a SQL managed instance from the portal to my environment on premises because I'm connected because I'm arced to Azure. Now, the other set of pods I want to show you through namespaces are these. These pods right here all represent what I would call the data controller. Okay, these are various pods running in Kubernetes that are going to do orchestration for us to control how things run in this Kubernetes environment. But what you're going to see at the bottom down here are these three pods. These are SQL managed instances. Why do I have three? That's because I'm using the preview of Business Critical. Wait, that name sounds familiar. Business Critical from Azure SQL Managed Instance. We have the same concept in Azure Arc. And why are there three? Because behind the scenes, we've done a built-in availability group. So there are one primary and two replicas going on right here. And when I go to Management Studio, this is my primary that I'm looking at. And in fact, how do I know that? I can click on Always On High Availability. Look at that. I can see that I am a primary replica. And then if I go over here to this one, I can click on Always On High Availability, and I can see that I am a secondary. Now, here's the thing you're going to love. In Azure SQL Managed Instance, when you run a business critical service tier, we put system databases in the availability group. Yes, so SQL agent jobs get moved over in failover scenarios. We do the same thing here. And here, I'll prove it to you. What I'll go here is I'll look at my dashboard for Always On Availability groups. And if I click in and take a look at this, you're going to see in the availability group a couple of things. You're going to see a database that I have, and look at that. You're going to see master and MSDB show up as part of the availability group. So now, in this scenario, when I create a SQL agent job and I need to fail over to the secondary I'm showing you here, it all works automatically. And so how does failover work? Like you just said, it's like automatic with Azure. We're going to use the power of Kubernetes. We're going to install a series of agents, and Kubernetes has built-in detection logic, kind of like a Windows failover cluster, to help decide should we fail over a pod to another one we have running. Since we're running replicas like Business Critical in Azure SQL Managed Instance, it's like an availability group failover. So it's very, very quick. As opposed to if you didn't have availability groups, kind of like general purpose. And guess what? We have that too. In Azure Arc, we have a general purpose service tier, which is going to behave like a failover cluster instance because in Kubernetes, your databases are in shared storage. In that case, in the case of Business Critical, we will put them in local storage and we'll replicate it. We'll have local replicas of it, just like you would have an availability group. So that's the power what Azure Arc's providing to you. It looks very much like a SQL server. Looks like an Azure SQL managed instance, but it's running in your environment. And then the last thing to show you right here is Azure Data Studio. We've created an extension for Azure Data Studio to do things and show you things like dashboards. So if I go click over here, I can do what's called a Grafana dashboard, and I think I've got it up for you. Yeah, here we go. So Grafana feels like Perfmon. Because Grafana is a great technology, we can provide this to you in Azure SQL Managed Instance. So you can run this dashboard and get statistics that look just like SQL Server stats. Or if you prefer to get more node information like operating systems, you can get actually down to CPU utilization, memory, and even disk performance. So you can do some monitoring in the Azure infrastructure, or you can do some local monitoring with things like Grafana. So that is really a good summary of the kind of things providing with Azure Arc. Now, you're sitting back to yourself asking, I have no idea now what to use when. Bob has presented me like 8 options to run SQL Server in edge environments, in on-premises environments, in Linux containers, in public clouds like Azure, or arcing in some sort of Kubernetes environment. I'm not even sure what makes sense to what. And so I provided this table. We won't go over this table, but if you look at this, it gives you kind of an overview of what's possible for you. So if you need instance level functionalities, for example, notice you have a lot of options here available to you. If you need SQL agent jobs, you're not going to get them in Azure database, but you can get them almost everywhere else. If you want to lift and shift to the cloud, notice the choices I have picked right here, VM and managed instance. Or if you want to go through and have the operating system of your choice, notice you have different options as well. So take a look at some of these scenarios. They may or may not apply to what you think of in terms of how to use SQL Server. And don't forget this one thing. It's very, very possible and almost very likely that you're not going to just pick one. You're going to want to run SQL Server in different environments. But remember back into your head here that we've done a very good job in the sense that the T-SQL language is compatible across everything I'm showing you. It's the same database engine with major functionality that you know and love all the time, and your tools are all compatible. I just showed you managed instance connected to Management Studio, connected to Azure SQL Managed Instance, but also connected to Azure Arc. And it almost looked like the same thing I was connected to. So very common, popular tool to use, but I also show you Azure Data Studio where we can extend it and do some things with Arc that would not possible to do that with Management Studio. Okay, so this is called future data driven, right? What are we doing for the future? So here's kind of the way I would look at it. We are going to continue to unify SQL across the cloud and on-prem. This idea of hybrid is going to continue to get moved closer and closer. It doesn't mean that we're not going to still invest in SQL Server. Many of you right now are asking yourself, Bob, when is the next version of SQL Server? I'll just put it out there because everybody wants to ask me that question. We are actively working on always the next version of SQL Server. We did it the day we shipped SQL 19. In fact, we did it before we shipped SQL 19. We're not ready to announce anything today, but stay tuned because we love SQL Server. That product is not dead. It's alive and well. But guess what? SQL Server is alive. That's why I did SQL Edge to Cloud. It's alive everywhere you've seen it. So in Azure Arc Managed Instances, a lot of the great capabilities you know and love in SQL and new innovation will get pushed into there. In Azure SQL, we kind of do like cloud first as a way of developing and innovating on SQL Server. So we kind of start there a lot of cases. So new innovation happens there all the time, and then eventually push to things like Azure Arc or to SQL Server. So we still believe, though, that a lot of customers want to take wherever SQL runs and tie it to the cloud, tie it together in a way that makes it very seamless and just leverages, instead of reinventing the wheel, why not leverage things that exist somewhere else? I think you're going to see us invest in developer scenarios more than ever before. Ensure that we're supporting the latest frameworks, the latest language, really push hard to invest things like JSON data types, graph types, and even IoT technologies, because we realize that current developers like to use those things and like that kind of types, those scenarios. The SQL Server, Azure SQL, SQL Edge to Cloud product line should support all of those ways and not just support them, but be innovative in those spaces. We think that hyperscale and serverless as architectures, whether it's really unlimited scalability or scale as you need it and pay for what you only use, we think those should just be built in to like Azure SQL Database. So you're going to continue to see us invest there and kind of make those more feel like just things that work, whether you choose those, we just do that for you, say you just want a database. That security is just paramount. Like if you don't have security, you don't have a database product or a database engine, you don't have data. And so we will continue to invest in Azure SQL Edge to Cloud across the board on enclaves. You may have seen us announce the general availability yesterday of Azure Purview. We believe that is a technology that's really powerful to help you govern things. We're going to start linking things together to that. And then Ledger, a new technology we announced for Azure SQL Database. We'd like to put that wherever SQL lives. And that is going to give you the power of blockchain, but using the power of SQL Server together. So check that out. You can even do a preview test drive of that today with Azure SQL Database. And then if you think about what we talked about today, Edge to Cloud, we do believe it's a modern data platform wherever you run it. I mean, think about the built-in database intelligent technologies I talked about. Think about data virtualization with things like Polydata and big data clusters. Think about the ability to do analytics through data virtualization or being able to do machine learning, whether that be in an IoT device running Azure SQL Edge, whether that be in a managed instance, an Azure Arc, or even SQL Server on-premise. So these are some of the big bets we're making for SQL Edge to Cloud. And I'm excited about it because we never sit still in this organization. I'm privy to this on a daily basis to see the amazing innovations our team put together. And I think you're going to continue to see that from us. So I know you want some resources. You just poured a lot into my brain. And at the upper right-hand corner of here, I want to emphasize again that today the deck, right now, as you watch this presentation, is up on this website. There's a folder called Future Data Driven 2021, and the deck is sitting right there. All public information for you. And a lot of demonstrations I showed you are available here today. Now, one demonstration I want to jump to show you is right here. We just announced, my colleague Buck Woody and I just built a new Microsoft Learn module called Azure Arc Enabled Data Services. So if you want to get started very quickly on Azure Enabled Data Services, Azure Arc, go take a look at that learning module. It also references something called Azure Arc Jumpstart, which is a really great program to help you get quickly started with Azure Arc. Now you might think to yourself, I want to develop with the Edge. So we've got a great place for you to start how to do that. Did you know that you can go build an Azure SQL Edge application all in Azure Virtual Machine without an IoT device? So you can do everything you need to do to simulate what it's like to build an Azure SQL Edge application, do it in a VM, and then literally go roll and deploy that to like an ARM device wherever your needs exist. You want to get started with containers, you can go here. If you want free training from Microsoft, and not just a training organization, which you have many of them and they're lovely. All of the stuff you see on this website was built by the engineering team, all of it, including free GitHub open source workshops. Yeah, that's true. We're open source presenters. Everything we do is free to the public. And so we use GitHub in many ways as a way to do that. But you may have seen Azure SQL today and you're like, you know what? I'm a SQL Server person. I kind of like that Azure SQL thing. My company may have kind of told me I need to start learning that technology. Go to Azure SQL Fundamentals right here. It's a Microsoft learning path built by myself and my colleague, Anna Hoffman. You go there today, and then you combine that with going to our YouTube channel, which are some 60 plus videos. You can get started today with a free Azure Sandbox. Yeah, you don't have to pay anything for an Azure SQL database to go through our training. We've had people tell us, this isn't something we intended actually, people have told us they've gone through these training modules for free and been able to pass certifications from Microsoft for Azure SQL. So go check that out. It's been very popular for us. We love Microsoft Learn as a pathway for people to learn, and we're going to continue to invest in that. Again, don't forget to go to this site right here to learn everything you need to know about migration, or we spend a lot of time now in this space because we want you to be informed. Marisa Brazil, a colleague on my team, is one of the most amazing people I've ever met. I can't keep up with her. Go follow @Azure SQL. We spent a lot of time looking around the industry, looking at the community, looking within our own team, and ensuring that on there you get the latest and greatest. And one of the things that we advertise both on Azure SQL and the digital content link is something called Data Exposed. It's a show. It's like Anna Hoffman's like a rock star right on this show. I feel like I've been a guest on there. I feel like I'm a guest host on Jimmy Fallon or something. So she runs this show, and a lot of times what she'll do is do monthly updates of all the latest and greatest that's going on across SQL Edge to Cloud. And then why not do a shameless plug for books? I spent the last 3 years, I'm taking this year off, but I spent the last 3 years writing these 3 books, one on Linux, one on SQL 19, and Azure SQL Revealed. The Azure SQL Revealed is, think of it as Bob's view of comparing SQL Server to Azure SQL. It's a very in-depth analysis. One of the things that's fun about these books is all 3 of them have, the first chapter is the history of these projects. So if you kind of want to get a behind the scenes look of how we built something, I think you'll enjoy that. Great. I was so honored that Scott Guthrie wrote the forward for the last one. Rohan Kumar wrote the previous one, and then Slava Oaks wrote the Linux one. So some great, superstars in our industry and our company helped write the forward for the books. A lot of great people involved in those. I do a lot of interviews even with the engineering team on how they built things. And then Anna Hoffman and several people on our team wrote a really, really fantastic book about how to do development with Azure SQL Database. Remember, we said that Azure SQL Database is a great place for you to get started for cloud-born applications. If you have that need today, go get this book because they'll give you a soup to nuts survey of all the tools you need in Azure to go build these things with Azure SQL Database. So crazy amount of information, but a lot of resources for you. I'm going to leave this screen up right now. I'm going to take a look at this question I've got up right now, but I also want to make sure that you take the time to post any other questions in the windows because we have a few minutes left to chat and learn from each other. Where do you find SQL Monitor on an Azure SQL database or on the server? I don't see that option on my local copy. Yeah, thanks for asking that, Kevin. So here's how that works. If you can go look it up today, you can go look up on the web SQL Insights. What happens is that you provision a very low cost, very inexpensive Linux VM, okay? And we have a wizard for you to go through and do that. So you go provision this VM through our wizard, and you go in there, and we're going to install Telegraph software, open source software in there. Then you're going to go configure the monitor through the portal, and it's going to push things down into the VM. And you're going to give it connection strings. You're going to say, oh, here's my managed instance. Here's my Azure SQL database. Here are my VMs. Once you put those connection strings in, the monitor will then start poking those things. And here's the cool thing, using standard like dynamic management views to pull data into the local Linux environment, and then use Azure Log Analytics workspaces to push the results. So you can see it's open source published of what we're collecting, what queries we're using. So you can go look at those kind of things, but you can take the results in Log Analytics and do whatever you want with them. You can publish them in your own website. You can use them for your own analytic purposes. You can keep them around for a very long period of time and do your own historical analysis. So the whole monitoring idea is separate the monitoring from the actual deployments and then monitor it from an external way, but hooked into the Azure Monitor ecosystem itself. When I try to go to your link above, it resolves to OneDrive MS and gets blocked by security reasons. I don't know if you mean this link right here. Let's see if that works for me. There we go. So I'm not sure why you're getting blocked, Kevin. I don't have anybody recently tell me that's been a problem for them. Please reach out to me at bobward@microsoft.com, and I'll try to figure out why you can't get access. I want to make sure you get access to certainly those resources. It is a OneDrive, my own personal OneDrive, but I've restricted that presentation folder where it is to make that open for anyone. So please reach out to me at bobward@microsoft.com, and I'll make sure you get access to anything you need. And by the way, I have to admit, it's not a very organized folder out there, but it does contain just about every presentation I've done back for the last 10 years at least. So those are free for you to not only just use, but reuse. I only ask that you contact me if you plan to reuse this content for your own purposes, just so we make sure that you have the latest and greatest. Yeah, that could be right, Kevin. You could be blocked on your own ID department. That's possible. Because I use that link a lot, and I don't have anybody that's told me that they've had a block on that. So, but anyways, yeah, reach out to me if you still have a problem with that. So we have a couple minutes left. Any other questions that folks want to raise on our call?
Yes, Bob, there is a question by Radu. If you
Okay.
just go a bit up.
Let me go up here. Is there additional cost for monitoring SQL Server in Azure, including the cost of SQL Server? So Radu, the SQL Monitor I mentioned is an additional cost, but what you're paying for is only two things. You're paying for the VM that you have to provision, which is an Ubuntu Linux VM, and it's very low cost. Like we use one of the lowest sizes that you have. So you got to pay for that because it's going to be doing the monitoring. And then you pay for the storage of the Log Analytics workspace that gets provisioned with it. But you don't pay for anything else. That's it. Okay. Any other questions anybody has? Rick, I hope I dispelled a lot of the myths of Azure Arc to you. Go check out though, Learn Azure Arc Data, aka.ms, Learn Azure Arc Data right here. In fact, let's have some fun here. Let's click on some stuff. Oh gosh, let's see what happens. We'll bring up the website. Is it going to work? Come on. There we go. So you see it's a Microsoft Learn module on the Microsoft Learn site. And here we go over exactly how this works. And then we even have really cool like architecture diagram. Look at that. You even got an architecture diagram for how we build the software. So check out that for Azure Arc. I know that's a new software we've done. A lot of people are still kind of trying to get the feel of what that looks like. So thank you so much for hosting me on your show today. I love the concept of future data driven. I hope you understand that we're heavily invested in the future. And I do hope that what I've done today is give you a very good idea of where you can head with your SQL.